Cisco Security and Log4j, when patching is not an option. Chaotic end to 2021. Log4j caused another year-end disaster for defenders, with yet another vulnerability that hits just before Christmas, impacting millions of devices and causing chaos for defenders. In this session, we will revisit the threat and opportunity that defenders have building a layered defensive posture when patching is not feasible. This session will be hands-on, showing the threat being realized without defensive capabilities, and then we will advance our controls while validating the results leveraging Cisco Security stack of capabilities. Layers matter, and this will highlight the value while significantly reducing risk, proven with focused outcomes. This will also prepare you for future vulnerabilities and overall risk mitigation, leveraging everything in the defender's toolbox. Let's get started. All right, CISA has issued an emergency directive, and this is really recommendations around mitigation. The ultimate recommendation here is to patch your systems, specifically internet facing, but ultimately all systems. The reality is that you're never going to be able to do that in 100% of the environments. And so there's an opportunity to mitigate risk through other means. Now, this is a great visual provided by the Swiss government's GovCert team around JNDI and the attack and some of the opportunity here. Now, I think we can expand on this, and we're going to walk through this a little bit more detail as we move along. But the goal here, at least in this scenario, for whatever reason you can't patch, then maybe things like web application firewall can mitigate the opportunity here for the adversary to take advantage of that vulnerability. How? Well, it's looking for a specific string that the attacker or adversary is trying to pass to that vulnerable system in hopes that it would execute it and then reach out to their malicious LDAP server, and the fun begins. So there's one opportunity. The other is disable Log4j, maybe patch Log4j. Obviously, that's the ultimate goal here. You can also disable JNDI lookups and disable remote code bases. Now, the thing is with disabling certain functionality, if the adversary does get in, they could potentially use these systems to get their tool sets onto these systems and then move them into the environment themselves by just turning on or reversing some of the changes that you might be doing with configurations. And so again, having multiple layers here is an advantage, even if you do patch. So the first thing that we're going to look at here is a risk-based view of vulnerabilities that are in our environment. And we're going to use Cisco Kenna to provide that insight. So let's jump right into it and let's review what we can see with Cisco Kenna. Cisco Kenna and Log4j. We're at the default homepage here where we see risk score, vulnerable assets, vulnerabilities, fixes, and mean time to remediate. But we're going to focus on the vulnerability at hand here. Now we've jumped into Explore where we see top priority, active net breaches, easy exploit, predicted exploit, malware exploit, and popular targets and zero-day vulns. Now we have our assets here and we have them listed, and our scores. We've got vulnerabilities and where they're associated, and then fixes if there is any. And we're going to drill into a couple of these in a second. Now we can search on all kinds of different things. Asset terms like IP or host name, vulnerability terms, CVE, description, fix title. You've got advanced syntax, and then tips and tricks. So some easy ways of searching this database to find what you're looking for. We're going to look at CVE 2021-44228, and we've got a couple of hosts at risk here. And we're going to focus on Ubuntu. So 10.8.1.3. Let's go ahead and pivot. We know that this is a dangerous vulnerability, and it gives us a high-level description right here. We can see that it's remote code execution. We also see it's a popular target. It's malware exploitable, easy exploitable, and active internet breach as well. And there is a fix available. We all know that, right? Patching that system. Now I can go ahead from here and set the status to open, closed, risk accepted, and false positive. I can do some edits here as well with notes and due dates. But in our case, let's go ahead and drill into this specific event. Now we get a good description. We've been through this already. We know that this is a dangerous vulnerability. If it's internet facing, we certainly need to patch it. Reality is we can't do this every single time for every single asset. But knowing what we need to do in order to mitigate risk is incredibly important. Now here we get to see any of the known exploit that exists out there today. Here's an HTTP scanner, and we can use the Metasploit framework to take advantage of that. We can also look for exploits that might be available. And this one here is Log4J shell POC. All right, as we move along, we can see there's some known malware here as well. And again, this is dynamic and will be updated as new events take place. And on our right side here, again, reference to our asset. I've just pivoted back to our asset 10.8.1.3. And we can see last seen created, operating system, the priority of any tags that might be associated with that specific asset. Pretty cool and powerful stuff. All right, that was pretty neat. So we've got some insight. We know at least 1 or 2 or 3 specific assets that we might have to focus on. Again, this is a high level alert. So in this case, the risk is high regardless. But having a risk-based platform does put things in perspective and allows you to prioritize the systems that you need to mitigate first. So the next thing that we're going to do is an orbital endpoint scan. So we're going to actually be able to go out and scan a fleet of assets all at once, come back and pull that data in and determine multiple different things that might be happening, whether or not we're vulnerable, attempted exploits, but it gives us quick insight into our environment of where the risks might lie. Now, you might say, well, wait a minute, we just looked at risk-based vulnerabilities, right, using Cisco Kenna, so why would I have to use Orbital? Well, there's a couple of reasons why a layered approach is always good. There could be things that are missed in either platforms. You might not have agents installed, and so you get different perspectives and insight. Not only that is you may not have all of these tools, and so you're going to use what's available in your toolkit. So let's go ahead and jump right into Cisco Orbital and check it out. Cisco Orbital and Log4j. All right, we're going to use this tool to scan our entire environment to see whether or not we're vulnerable or whether or not there's been attempts to exploit. So here we're going to go ahead and we're going to browse for the asset. I got one specific asset that I'm going to target here. Obviously, you would add the number that you are interested in. We're going to go ahead and select the query. Now, this is a nested query, and it's focused on Linux. And a nested query just means we can run multiple queries and be very efficient at the same time. Now let's go ahead and we'll run this query and then we'll walk through each. So the very first query that we're going to see is installed packages related to Log4j. The next query is really looking at config parameters, again associated to Log4j. The next one is loaded modules associated for Log4j, and you can see a lot of them here. The next one is looking for versions that might be running. And then finally, the last 6 queries are looking for exploitation attempts. And we can see a couple of them here. Multiple log files showing attempted exploitation that is happening in our environment. And so this is great insight. Not only do we determine whether or not we're vulnerable, but whether or not we had attempted exploits against these systems. And that tells us a couple things. One is, we may have been compromised. The other is that we better get some mitigating controls or patch these systems very, very quickly because they're actively being targeted. All right, we've got another system here that we've identified. We know that there's been an attempted exploit in the environment. And now we move on to the next phase here. And again, we haven't done anything to mitigate. So in fact, the recommendation so far by CISA has been to block using web application firewall. We haven't in fact done any of that yet. But what we are doing is learning our risk profile. We're understanding what it looks like in our environment. And so, as I mentioned just previously, you may not have an agent for everything. And so there might be systems that are introduced in the environment that may be exposed and you have no visibility into it. So scanning and understanding the behavior of the network provides tremendous amount of telemetry. And this gives us an opportunity to look for all kinds of different things. We can search for past evidence of exploitation using secure network analytics from Cisco. We can set the range. We can detect future malicious communications by building policies that alert us and watch for specifics in the environment. We can look for payload data for this specific campaign. We can search for abnormally large LDAP queries. Again, another indicator here. We can use our custom security events to look for these abnormally large LDAP queries. So we can do one ad hoc, but then we can build this so we can identify this moving forward. You can also use cloud secure analytics for IPs that are associated with this campaign. So there's all kinds of different capabilities that we're not going to be able to show everything. So I'm trying to give you as much insight in this session as possible here. But we can use the global threat alerts to determine whether or not Log4j scanning and malware installation is, associated to things in our environment. But nothing better than jumping in and checking it out. So let's go look at Cisco Secure Network Analytics. All right, we're in Cisco Secure Network Analytics platform. You can see there's no alarms here. This is a brand new build specifically to catch anything to do with Log4j. Haven't baselined the environment, haven't really done anything. So the first thing we're going to do is that we're going to go ahead and create a Log4j watch list that we're going to capture from Telos. So let's go ahead and create that host group. It's going to be an outside host group. Go ahead and hit add host group. We're going to give it a name. We're going to call it Log4j Watchlist. Okay, and then we're going to jump to Telos. We're going to scroll all the way to the bottom where they typically have all the indicators of compromise. And if we look here, we'll see the latest and greatest in regards to an IP list, and we can go ahead and capture that. And we can insert it into a text file, do editing, whatever we need to do. I'm going to go ahead and copy it and just paste it in here. And then go ahead and hit save. All right, now we have this host group, and we can use this in multiple different ways. We're going to use it in a custom security event or policy, and we're also going to use it just to do a quick search to see whether or not we have any risk to the environment. So we'll go ahead and create the policy first, just so we have it. We'll give this a name. A lot of times you'll see Cisco prepend this with CSC.log4j. I just calling it Log4j watchlist IPs. We'll go ahead and add an inside host. So anything on the inside of our network talking to a peer host group, the Telos IP addresses that are of concern. We'll go ahead and enable and save this. Now we have that event. Okay, so far so good. Let's go ahead and do a flow query. So we're going to go ahead and do a flow search. We're going to go back a few days, maybe 30 days, whatever it might be. But we're going to capture everything on the inside talking to that Log4j watch list. We'll go ahead and hit apply. We'll change the time frame to 30 days, and we'll go ahead and search. Now remember, this takes flow data in from your environment. So this could be firewalls, this could be switches. All of that feeds the telemetry into the network analytics platform, and then it does its magic around baselining, artificial intelligence around things like encrypted traffic and so on. The good thing is we don't see any events here. So we're clean in regards to that, at least that IP list. But let's give it a test. Let's see if we can actually detect an event. And again, we're going to go ahead and put in an IP address. We're going to trigger the event. Again, this is a contained environment. There's no risk here. And remember, Stealth Watch is out of band, or Secure Network Analytics as it's known today is out of band. It's taking flow data, in this case from Firepower, and feeding it into the flow collectors which allows Stealth Watch or Secure Network Analytics the ability to search that data as needed or trigger alerts based on behavior. All right, so we're going to go ahead and do another search here, but we're going to do the last 10 minutes. Again, inside to those Log4j watch lists, and we should see something if things are working correctly here. And the beauty of this, and we did, right port, right destination, this is exactly what we wanted to see. Now, this is a manual search, but this is a good indication of compromise. Now, it's going to catch anything in regards to misconfigurations on firewalls, lateral movement, anything. You can't hide because all of that telemetry or metadata from the networks being shared to Secure Network Analytics. Now you can see here, this is the host summary, so we get a good idea of the host groups, where it's communicating, and any security events that's tied to the specific host. Here we're looking at sources, and we can see that we're certainly have some denied entries, as well as a connection to that watch list that we were looking at. There's some application traffic data, and we can see volume of data as well. Now, when we jump back to the dashboard, we can see that there was a policy violation. Now, this is the policy violation or that security event that we created that triggered this policy violation. So that's pretty neat. So that means we can do things that are really custom in regards to our environment. If we have an operational environment that shouldn't talk to the business network, we can watch for things like that. If you have a PCI network that shouldn't talk to the campus environment, again, we can build host groups to say, watch for any telemetry that comes from the network that suggests that they're communicating. And if they are, trigger an alert. Okay, so far, so good. Now let's go back to response management and let's go ahead and create a new rule here. So go add new rule, and we're going to add a host alarm. So let's go ahead and click that. Let's give it a name. Log4j Watchlist IPs. Why not? That's what we're looking for. It's enabled. You can put some description in here. And again, it's asking you here, rule is triggered if, in our case, any of the following is true. So we're going to say, in our case, type our custom security event. We're going to send an email when that event triggers. Pretty simple. Beautiful. That looks good. All right, that's pretty simple. Let's go ahead and save that. Next thing we're going to do is go to actions. Now this is the cool thing. Let's go ahead and create a threat response incident and have this automatically sent to SecureX. Again, let's give this a name. You might want to actually add response action maybe to the end of it. High level confidence. We know the IPs are bad. They've been suggested bad from Telos, and that's a trusted entity for us. We'll go ahead and test this to see whether or not it's working and everything is in line to what we expect. We'll save this out. And let's go ahead and jump into SecureX. And look at that. There's our test event here. Okay, so that's good. Everything's working. Let's go back to rules and let's go back into our event and let's assign this to our specific rule that watches for those IP addresses. So what's going to happen here is when an event takes place, we're going to send an email. We're also going to send the event to SecureX. That way you can go right into SecureX, start your investigation to see what's really going on. So let's give this a try. Let's grab a different IP address here. This 92.223.105.173. We'll go ahead and enter it in here. We'll log in to our application. It's going to try to do the LDAP query back to that specific host. And look at that. We've triggered an event. Here it is here from Secure Network Analytics. There's our Log4j watch list. There's that IP address. The severity is high. Now what we can do right from here, we can actually jump into threat response. and get a different perspective of what might be going on. We know that this asset made a connection, but what else might be going on? And look at this. Once we zoom in here a little bit, now this is going out and reaching out to all the telemetry sources that it has, firepower, stealth watch, endpoint, email, whatever it might be. And you can see, look at the story here. We've got an endpoint. There's that IP address that it connected to, but we've got a malicious SHA. We can pivot from here. We can do a forensic snapshot. All of that at your fingertips. Pretty cool stuff. All right, so we've got some good insight at this point, but let's get into mitigating some of these controls. And so again, we've got lots of opportunity here. So the first one we're going to look at here is block with WAF. And so we're going to use Cisco's web application firewall powered by Radware. We're going to show exploitation, the adversary taking advantage of the asset, and then we're going to put our mitigating controls in place. Once we've done that, then we're going to test again and see that the adversary no longer can proceed with attempted exploitation. So ultimately, we're looking for success here of mitigating that specific risk. Now, as I mentioned, as we start adding these layers, I think you'll come to the conclusion that it's very, very difficult for the adversary to be successful. And there's other reasons why you want a layered approach. One of which would be is that even if you get that internet-facing system mitigated somehow, they might be able to get into the environment a different way and use Log4j to move even further or laterally within the environment. So again, layers matter. All right, let's just jump into Cisco WAF powered by Radware. Cisco Web Application Firewall leveraging Radware. Log4j. All right, we've got our netcat listening, and we've got our malicious LDAP server and our web server that's going to pass back that malicious payload. So let's go ahead and see what happens here. If everything is working, we should get a reverse shell, and we do. Let's go ahead and see if the payload was delivered. We know that because we've got the reverse shell, but we can see a success of 200 here as well. So let's go ahead and enable web application firewalling. We already have a VIP installed and ready to go, but we need to install the security elements specifically for web application firewalling. So we're going to give this secure web application an ID. We'll call it log4j-web. And in fact, we're going to use the same name for the name itself. Good to go. App wall service enabled. It's going to be inline and we can submit, but let's go back up there and make sure we enable secure web application. Okay, go ahead and submit. And there it is, the details around it. Let's go ahead and save it and make sure that we apply and everything looks successful here. Now, this does nothing at this point. Think of this as an object. The object's created. You can leverage the service, but we need to apply it. So let's go to application delivery, our virtual services, and we're going to go ahead and edit our virtual service and go ahead and add that secure web application that we just created. All right, we'll go ahead and submit and we'll save. Everything looks good so far. The next step in this is that we need to now go ahead and configure the web application rules that we want to trigger on for Log4j. So Radware has a collection of strings that we need to look for. So let's go to security. Let's go to secure web application. And we'll go ahead and edit the security policy now. Now we could have done this beforehand before we applied it. Doesn't really matter here. In our case, this is a lab environment. Okay, we're going to go to configurations and let's check out a few things. We're going to go to tunnels and Log4j web. And you can see there's a bunch of settings here. General properties, host names that we can add, HTTP properties, parsing properties, HTTP message size, security bypass, and then there's also tunnel mode. We're going to jump back to security policy. So let's go ahead to our Log4j web application firewall settings. All right, we're just going to quickly set an internal security page here. This is going to have a reference ID attached to it. So when you go to the site itself, there's going to be a message. There's also going to be an ID there that we can reference, and that we can reference that in our log files. We'll save and apply this. All right, we're moving along. So let's go to vulnerabilities, and we're going to go ahead and add a custom pattern. And this is going to be URL header and parameters. And I've got a list of them here that we're going to go and copy and paste. We'll do a couple, and then I'll just add them all here. But the first one is looking specifically for $JNDI. The other one is looking for the JNDI : LDAP. And then you can see RMI, DNS, and we'll go and continue to add these as we move along. So we'll do one more, and then I'll jump to and skip the rest of them, but I will have them all added. All right, all added, work is done. Now we could also click where used, and we can go ahead and submit it. So where used is going to let us know where we're leveraging this. So let's go ahead and apply this. We are good to go at this point in time. And let's go ahead and test it. So we'll copy that selection here of that string. We'll go ahead and insert it. We've got our netcat listening. And there's that case number ID. So that ID number that we inserted in the web page will help us parse the logs specifically for this activity. And you can see there's no shell access whatsoever. So we can take this number, and again, we can filter it in our logs. Okay, let's jump back in here for a second, and let's go to forensics. Let's see, we definitely did not get access. But let's go ahead, and we certainly do have some pattern violations that have been detected here. So there's the time, the severity, generated by, reported on. There's the host, the application path, the description. And then you see here, there's the URI, any parameters, and then the parameter value. We certainly have reference to that. And that transaction ID was actually over on the left side. So that case number actually was also embedded in the logs. Okay, so that's good if you had to manually do it. But in reality, we have the ability to use the AppWall signatures. If you have automatic updates and you have AppWall, again, I tried to do the attack here, and you can see the AppWall signatures were enabled. So I didn't have to create that custom WAF rule sets that I did just previously. In fact, I removed them. All right, we see that that has triggered an event here, and it looks a little bit different. First, it has this icon under refined, but also the threat name is different. It says code injection versus input validation violation. The results are the same. We were able to mitigate the risk, but one was that we had to create a rule set versus the other that automatically is updated. So if we go jump into the event itself, we see there is a pattern ID that's associated, and the description is very specific to Log4j. All the other details exist. Pretty neat. Well, I think you have to admit it was pretty neat watching that, the adversary's viewpoint of how they get access to the system, and then ultimately seeing how we can mitigate that and seeing the results live. All right, the next piece is that we've got the ability to leverage intrusion prevention platforms. So again, you've got web application firewall that's higher up in the application stack, but you also have the ability to look for things at the network layer. And so we can mitigate here using intrusion prevention. We can also leverage network malware to block known hashes or known malware associated with campaign. And then we have the ability to leverage just the firewall simply by blocking outbound access to some of the protocols that are being leveraged to take advantage of Log4j. So things like LDAP outbound. If LDAP is required to call back to the malicious system and I don't allow LDAP outbound, then obviously the adversary can't take advantage or move forward with their specific campaign. All right, let's just jump into Cisco Firepower Threat Defense and check it out. Cisco Firepower in action. All right, let's go ahead and start up our Netcat listener. We'll go ahead and start the attacker machine. It's the same machine that we're listening on. This is going to get the LDAP server, or the malicious LDAP server, up and running, as well as the web server that passes back the exploit class to take advantage of the vulnerable system. Now the goal here is to pass this string to the vulnerable system. It's going to log it and then do the JNDI lookup, which is going to reach out to our LDAP server. Once it does that, we're going to obviously pass back that exploit class and take advantage of that system. So let's go. Go ahead and hit login here. Now this is passing through Firepower, but in detection mode. So we can see that we did get reverse shell, and that's expected, in fact, because we're not doing any blocking. There's no security intelligence enabled. It's pretty clean. Other than a couple of rules have been created to allow to connect to the web server in the DMZ zone, as well as having the ability to do detection. So we're going to be able to see, or should be able to see, an alert in Firepower. So you can see here we're navigating on the system. We had access. All is good. Okay, so let's go ahead. I'm going to go back, refresh this so we can get ready for a test once we validate that actually detected the event. Now we're in unified events here, and look at that. Here it is. It says would have dropped. And the reason why it says would have, it's in IDS mode. And there we go, the intrusion message. Indicator of compromise. LDAP's the application, client application's LDAP client. And we can even see the web browsing to port 8000. That's the adversary is housing that. And 9001, that's our Netcat listener. Now let's go ahead and check our IPS rule here. Now the reason why we didn't block it, as I mentioned, even though it states block here, on all of them, it says block by default. The mode was detection. So let's turn this to prevention. That's saved. That's good. Now let me just jump to policy so you can see how it's pulled together if you've not seen Firepower before. And let's jump into our access control rule. And this is the rule that allows access from the internet to that DMZ web server that's vulnerable. And let's go to inspection. And we can see there's that intrusion policy. So we're good to go here. We'll save that out and we'll go ahead and deploy this policy. Go ahead and hit deployment, select the device, hit deploy, add some information. We're good to go. That'll deploy. That'll take a minute or so. We're not going to sit here and watch that. That's not why we're here. So I'll fast track that. Let's jump into analysis. Go back to unified events to get ready for another attempt here. Let's see what happens. Now, let's get our Netcat listener up and running. The adversary components that we need in order to connect back to us from an LDAP perspective and web server is already up and running. We did that just a few moments ago. Let's grab that nice string that's going to get logged and leverage JNDI to do the lookup, and bad should happen, right? Now this is going. Let's check our terminal here, and nothing seems to be coming back. Okay, well, let's see. Something happened, that's for sure. Oh, look at that. We see an intrusion block here. So we can see that there's an intrusion. It was dropped. If we drop that down, there's the details, right? Indicator of compromise, JNDI, LDAP, client, all the details. And here's the block action as well. The client, LDAP, we know, application ID, all that good stuff. Okay, so that worked as expected. Now let's just go into the intrusion events itself and dig a little bit deeper into the data. Now we can see two events here, and that's exactly what we should see. The adversary's 255.129, but it says would have dropped, and the other one is dropped. So whenever you see would have dropped, that means you're in detection mode, and dropped obviously means it's dropped the packet and in prevention mode. Now when we drill into it, we get to see the rule, a little bit of details. We can actually take action right from here. So we can do a who is, we can add it to a block list. We could do some investigations right from here. We can also take actions as well. And the nice thing that we have here is the payload is available to us in the web GUI, right? We don't need to go in, download the PCAP, although we can, and look at it in Wireshark. Although we can, I can see it in the browser. Okay, so that's pretty neat. That worked out as expected. Let's go ahead and turn off inspection for a second here. I'm going to show you another way. Maybe you don't have an intrusion prevention system. So what can you do to mitigate that risk? So the one thing we can do is create a block action that not only looks at 1389, because that's the port we're using, actually looks for LDAP. Now, this would be a next-gen firewall capability if you're doing application-based control, but I could do it based on port, obviously fairly trivial to bypass, but I'm going to do it based on application here, just to show the next-gen capability. Now, again, we're not going to go through the deployment. I'll save you the cycles there, but we got to deploy because we are making a policy change. Let's go to unified events. Now, the goal here is whether we're looking for LDAP, the port, or the application. So depending on the firewall capability that you have, I have the ability to mitigate the risk, even though I didn't stop the compromise. So the compromise is going to happen here, right? There's not an intrusion mechanism to look at the payload, but it can't return the call back. You can see that there was nothing there in our netcat listener. And when we go ahead and check the connection events here, we can see that this was blocked. It's 1389. It just happens to be the port that we're leveraging here. We can see the application protocol, again, because we have a next-gen firewall. But again, if you control your outbound ports, you can certainly minimize your risk. Now, again, layers are going to matter. So when we go into connection events, we can also see that here. Block action and details about that block action. Now, what would you really do in the real world? Would you just have, if you had a next-gen firewall, would you just do, LDAP outbound? No, you would actually layer your defense here. You would have both the firewall type rule blocking outbound LDAP or any one of those protocols that are being leveraged, and you would turn on your intrusion prevention capability and mitigate that risk. So let's go ahead and deploy. This has now got multiple layers of defense in place. And remember, you would have security intelligence. So some of those bad IPs that Telos has marked as bad are going to get blocked. You're going to have the intrusion capability. So if there is a crafted packet or payload being sent, you can mitigate that risk. And again, you'll have that firewall rule outbound to minimize the risk. And those layers are going to help you win the game. So what do we have now? We've got our intrusion prevention system adding to what CISA is recommending. We've got the ability to use the firewall to block outbound connections to LDAP as an example. And we've got the web application firewall. So we're starting to build these layers into our environment. The other element here is leverage DNS and web proxy controls. So we can use DNS layer security to block certain threats early. And Cisco Telos has provided some sites here that have been marked as malicious and part of Log4j and the campaign itself. And so having our security categories at the DNS layer is a very efficient way of blocking. So if there is a request back out to these domains that are known to be bad, and again, this updates over time, and it would update automatically and start mitigating risk. The other element here is the cloud-delivered firewall with Cisco Umbrella. So if you're using the secure internet gateway functionality, you have the ability to leverage the cloud-delivered firewall, and we can actually block LDAP and LDAP-S outbound using this cloud-based platform, just like we did with Firepower. And then we have IPS, the ability to turn this on and mitigate against exploits that are associated with Log4j. Again, we've seen this in Firepower. This is a cloud-delivered platform. The addition here, though, is if you weren't using the firewalling functionality or the IPS functionality within Cisco Umbrella, you certainly had an opportunity to leverage the DNS mitigating element of the platform. And again, doing it at DNS provides the ability to mitigate risk earlier on. Web proxy to filter traffic, again, leveraging Telos intelligence. So now we're at the web proxy layer. And so, DNS is that first attempted to resolve. There's no initial connection to the adversary itself. The next is if you're able to resolve with success, then you're going to be redirected to a web server. And if you can proxy that connection, obviously you have an opportunity to analyze and mitigate. All right, demonstration time, Cisco Umbrella. Cisco Telos has identified multiple malicious domains associated with Log4j campaign. And if you have Cisco Umbrella enabled, that first line of defense at the DNS layer is actually going to kick in and block any type of attempted resolution for those domains. And so let's look into one of these domains and let's get some insight into what might be happening here. We'll go ahead and grab it. We're going to go into investigate. This is a powerful tool that allows us to look up domains, IPs, URLs, etc., and get some insight. Now we can see the risk score is pretty high here. We see the current country of origin and the DNS queries over time. We can look at events and changes, and then the disposition history, so event history and the details around it. Any IP addresses associated, name servers that are being leveraged, other DNS information, and look at this, SHAs that have been associated with something that's relative to this domain, whether it be an IP address, etc. And here's the breakdown of that malicious file. All the behavioral indicators. We look at subdomains, we get good details here, and related domains. We get the whois information. Again, this helps us piece the bigger picture together, truly understanding how the adversary is attacking us. As we scroll down, we can drill into more whois data here as well. Then we have requester distribution. Now this is interesting because what it shows us here is where these domains are being requested from. So who's making the queries and doing recursion. And what's interesting here is if you're a .ru, for example, then most of your requests typically would be coming out of the region that the origin of the domain resides. So if you're a .ru, most of your requests would come from Russia. And so what you can see here, and this helps us draw out the attack infrastructure, is that if you had a Western country making many requests to an Eastern country that could be known as malicious, and many of your requests are going to that origin, that alone might indicate something that is suspicious. Again, the goal here is to empower you with information, not only mitigate the risk using DNS layer protection, but also providing you with the data you need to make the right decisions. All right, we're moving along here. We've got lots of layers now starting to come together. So we've got some stuff that's up front that'll block our assets from being compromised. If for whatever reason these fail at any point in time, we have an opportunity to mitigate any outbound type activity. Again, the adversary needs to be successful from start to finish. We just need an opportunity to disrupt that in certain areas, and these layers are certainly going to do that. All right, so what's next? Well, we've got workload protection. So segmentations, we have the ability to do that in the data center or in a cloud infrastructure. All of our workloads can now be segmented and controlled and only communicate with assets it should be communicating with. And so we can block hashes based on IOCs. We can block network connections, making any attempts outbound. Again, if you have a kind of a zero trust model within the data center itself. And when I say data center, I'm not talking about on-premise type data centers. I'm talking about microservices, containers, virtualization, on-premise, cloud, doesn't really matter, right? You should be able to extend that capability across all those disparate IT environments and centralize and be able to control that. And so we can identify assets with known processes of concern. So we can use this not only forensically to determine whether or not we have assets at risk. And then we can build policy on this. This is the really neat thing is that we can look for these specific assets with this specific hash. We can also stop it from communicating outbound based on our actual policy. So here's an example where we've used the Log4j Telos IPs. So we've collected those, we put them into a list, and we've said basically that web service or services that may be at risk for this can't communicate with those IPs. Now, you might say, well, why would I have to do that if I have firepower and we're blocking IPs? You're right. But remember, that's further up the chain. This is actually on the host before it even makes a network-bound connection outbound. Again, freeing up resources on firepower, but also blocking it as close to the asset, if compromised, as well as the goal is to block as far away from the asset as possible if the adversary is targeting it. We have the ability to restrict inbound and outbound using microsegmentation and providing least privilege. We have the ability to restrict lateral movement. This one's key. If you do get compromised, we don't want the adversary to have the ability to move. And this is where really zero trust comes in the data center. Ongoing monitoring and analysis. So we can leverage secure workload forensically to look for certain behaviors. This is a good one here. You can see the MITRE attack framework alignment. We can see that the version of Java being used here. You'll be able to see things like who is the user being leveraged for this particular process. And you can see at the bottom there, you can see the wget and the actual IP address and what's actually trying to happen here. So some good insight forensically as well in case of compromise. All right, enough talking about secure workload. Let's jump in and have a look. Cisco Secure Workload, microsegmentation at the workload level. Now we've got our Netcat listener ready to go. We've got our adversarial components with the LDAP or malicious LDAP server and our web server to pass back the exploit class to take advantage of the vulnerable system. So let's go ahead. We're going to give this a try and we should see some success here. We'll go ahead and log in. Let's go in now and have a quick look to make sure that we do have reverse shell, and we certainly do. Now, the next thing that we're going to do is let's clean this up for our next test. But the next thing we're going to do is go ahead and log into that vulnerable system. We're going to look at the IP tables that are in place. So we have secure workload installed on this asset. In fact, I've already ran the application dependency mapping on it. So it understands all of the communication that takes place on the system and makes recommendations for policy. Now you can see when we ran IP tables, there was nothing there in regards to policy. We're going to change that very, very shortly here. So we've got our workspace. Our workspace is a collection of rules that we can apply to workloads. And we've got these suggested policies right here currently. And so you can see things that are pretty common, right? 8443. We've got tetration as well is being called out. UDP 53 and 123, so DNS and NTP. So these are all protocols that we accept. We see ICMP. We're okay with that. SSH from an internal network, that's fine. And then there's a couple of other ports maybe we're not familiar with. Now, we could remove them here and run policy analysis to validate that we don't have anything that we're concerned about in regards to blocking access to that port, because there is a system that has been reaching out using that port. Now, there's 1389. That's that LDAP port. We don't want that. And 9001 as well. That's the reverse shell. So let's get rid of that. The other ones are fine, VMware vMotion and DHCP. Now, the catch-all in this case is a deny. So what we're going to actually do here is microsegmentation or application segmentation. And all we have to do is hit enforcement, and this is going to be applied in the Windows world as a Windows firewall, and in the Linux world it's going to be IP tables. And then you can also do this at the container level as well. So we're reviewing our policies here. So we've got a couple of allows. We've already validated them. We're fairly confident in what they are. And again, you can run policy analysis that does a simulation of the policy in place, but doesn't actually block anything. Now, because the catch-all is a deny, this is actual microsegmentation. If you had secure workload in place today and you didn't want to go full microsegmentation right away, you could use a policy and use that enforces maybe restriction of LDAP outbound as an example, but allow the catch-all to be allowed. So you mitigate a portion of that threat that's specific to this particular campaign, but you don't block normal communications or other communications that might be happening on the system. So let's go ahead and give this a try. Does it actually really work? Well, we don't have any communication back. We're not seeing any additional success here on our web server. Now, that was the original IP tables on the vulnerable host. Let's rerun it. Okay, now look at this. Now we can see a bunch of policies have been added. Now these are the policies that we've just went in and validated. SSH, port 8000, etc. So that's pretty neat and pretty quick. So if you have workload protection, you can certainly come in here and deploy a portion of this to mitigate risk, or go full microsegmentation and certainly remove the adversary's ability to navigate the environment. And look at that, we can see a rejected flow right there. That's that 1389. Now another option here might be is to go to Telos, grab those malicious IP addresses that are taking advantage of Log4j. And I've entered this into a CSV, and I've got two columns. One's an IP column, and the other is log Telos IP, and it says yes. So what I can do is I can create labels within Secure Workload very, very quickly, add this, upload it, and now I've got this label that I could use in policy. So what I'm going to do now is create an inventory filter. We're going to give it a name. First, we'll go ahead and enter Log4j Telos block IPs. If it equals yes, then we want them added. Look at that. There's 8,738 already added here automatically. Okay, perfect. Create. And now we have that available to us. So how do we actually leverage this? Well, I'm going to show you. Let's jump in to our workspace. So let me just check this here for a second. Edit filter. Let me just change the scope here to internet and save this out. Close this off. Now I'm using the scope internet because it's higher up in the scope tree. That's for another discussion. But now I'm going to go ahead in my primary workspace for my web services, and I'm going to create an absolute policy. But first off, we're going to change that catch all policy to allow. So remember earlier where I said microsegmentation, if you didn't want to go down that road or path and you wanted to mitigate risk specifically to a campaign or an event, this is how you would do it. You leave the catch all allow. That means anything else will be okay. We're going to add it to the Log4j scope. That this is where all our web services are. And we're going to say the provider is the Log4j Telos IPs. And any protocol, we're going to block that. There's our list of IPs there that we uploaded. And now is an inventory filter. We're going to go ahead and log into the box real quick here. And let's just check out the access that it has right now. So you can see I'm able to ping one of those IP addresses. Now let's go ahead and look at the IP tables of this host. Again, this is the vulnerable host here. And you can see it's clean. We haven't deployed to this host yet. So let's go ahead now and enforce this policy. Now this one's a little bit different than the last one. The last one was really microsegmentation. So here we go. This is the latest policy. You can see the deny absolute. We're going to go ahead and hit next. And those other policies that are there are going to be applied as well, but there's a catch-all, so it doesn't really matter. The point being here is that I could have a catch-all policy and still have a policy that denies specific things that may be risky for my organization. Go ahead and give a reason if you want, accept and enforce, and this is going to go ahead and push out to the clients within minutes. Go ahead and get ready to have a look here at any traffic that might be denied or rejected. Let's make sure that we are updated, and we are. So the policy is in place right now. It's being enforced. If we try to ping that address now, let's see what happens. Look at that, operation not permitted. Bam, it worked. Now, what if we go somewhere else, like Google? Success. So this is at the workload level. Now you can see how all these layers start to come together. If you had the WAF and the IPS and the outbound firewall at the network level, you've got DNS, you've got network telemetry, and there's all the rejected packets right now coming in. Perfect. But you can see these layers really matter, and they add to your defensive posture. Anyways, another opportunity to mitigate risk. All right, now we've got, a network lens perspective. Visually, we can see what's happening. We have the ability to understand our endpoints and whether or not they're at risk. We have network-based controls. We have host-based controls. What's next? Well, we can use endpoint protection to block known hashes or known malware associated with the campaign. And we can leverage email security. So we use Telos as an example, saw messages that are related to JNDI lookups at different locations within email, headers, subject lines, bodies of emails. Now, I wanted to cover these because these are also two opportunities to help mitigate risk. In this case, they're trying to leverage the most vulnerable asset, which is the human, and have them do the dirty work. So when we look at secure endpoint, Cisco has provided some good IOCs that have been updated to include Log4j related detections. Claim AV signatures are in place that help block attacks exploiting Log4j. And then you've got Cisco Secure Endpoint provides full endpoint detection response to ensure full contact. So again, forensically, there's a tremendous amount of data here. On the right side, you can see an example of this specific malware IOC targeting Log4j. And it's Log4 shell, and it's obviously remote code execution when an attacker controlled string is logged using Log4j. We talked about this, we've seen it in action. And you can see the tactics and techniques that are actually being leveraged here. So this again is additional analysis that's being provided to you, but it's an IOC that's going to get triggered if we happen to see any attempts here. Now that again, if you look at the full defensive life cycle that we built here, that means they've got to get through your IPS, they've got to get through your web application firewall, they've got to get through DNS, they've got to get through your secure workload and your protections there. They've got to get past the endpoint and any mitigating controls you have there. We've talked about web proxy and and it goes on and on and on to finally get to this level where the adversary was successful enough to trigger an indication of compromise. This is a tough thing to overcome from an adversarial perspective. So here's an example of the CLAM AV signatures that are available as well. Now, I wanted to provide some insight into an example. This comes from Telos. We have observed emails being leveraged here to exploit Log4j. And so, as I mentioned, it could contain malicious JNDI lookups at different locations, such as headers, subject lines, bodies of emails. And here's an example of that here. All right, so we've rounded this out now. We've got a lot more additional mitigating capabilities in the environment. Again, the goal here is to patch 100% of everything. You have SecureX now that ties this all together, and we can use SecureX to hunt within the environment against not only the Cisco technologies, but any third-party integrations that we might have. And so this is great because now we have the ability to be able to use this data as needed for a specific event, like Log4j. And then Telos obviously is powering all of this, at least from an intelligence perspective, but that does not mean you can't use any third-party intelligence to further enrich SecureX or any one of the products that we've talked about. Defense in depth matters, and hopefully you can see this here, that this makes it very, very difficult for the adversary to be successful. Cisco Secure.